Let us discuss two characteristics of software. So, software is engineered, not manufactured. So, this is a very important point. So, why? Software is engineered because it involves logical design and construction rather than repetitive physical manufacturing. Unlike hardware, there is no separate manufacturing phase in software. Once it is developed, it can be copied without cost or degradation. So you can understand when you talk about hardware development, it means what? It requires materials, requires the design. After designing, it need to be manufactured physically. There are physical components involved. Suppose you think of CPU, central processing unit. So when you want to develop the chip, so maybe there are other steps like what need to be done. Then you actually design in the computer. Then after that, you have to develop that. You have to manufacture that physically. So that process is called manufacturing, which is not there in case of our software development, because software is actually a collection of codes, and that is once it is written, there is no manufacturing phase, like physical components are not required in this case. It is fully a logical design and construction rather than repetitive physical manufacturing. So the once the code is written, it can be actually given to anybody, and there is no, like we no need to write the code again, we no need to develop the software again. There is a very huge relief in that aspect. Like suppose you have developed one chip, hardware, or any kind of component physically, then when you want to copy it, when you want to build another one, you cannot just copy and paste kind of thing. What you have to do, you have to again manufacture another unit of that particular product. So this way the software is different from hardware. So once it is developed, it can be copied without any cost, because you just have to copy and paste. No cost is associated. As such, software quality depends entirely on the design and development process. Means when you are actually designing and developing the software, there the quality of software actually lies. If you are very much focused in your software development, you are actually mapping all the requirements of the customer, then you are following all the steps in the software design and development, then you will have a correct product or quality product. If you lack in those phases of software development, then you will have a faulty product. So this is actually the difference in software and hardware making. Therefore, managing software projects requires a focus on planning, skill engineering, testing, and evolution, uh, not manufacturing logistics. Manufacturing, you no need to think of, just you have to think about the design, you have to think about the logic, you have to think about different modules, and all is done in the computer. So you have to be focused in your process. So treating software projects like manufacturing efforts can lead to a faulty assumptions. Like you should not consider a software engineering or software development like any other hardware development. Then you will actually lead to faulty assumptions about productivity, scalability, and cost control. You cannot compare these two like this, or you cannot go with the flow of hardware development when you are developing software. You have to take it separately. So this is one characteristic. So let us discuss another one, that is software doesn't wear out, uh, but hardware does. Wear out means what? It actually deteriorates over time. So software differs fundamentally from hardware in how it fails. So when you have a software, if you can just keep it in your computer, it will be there forever. But when you have a hardware, so over time it will deteriorate, and it will just decompose, it will decay, and it will not perform. So hardware is prone to physical degradation due to the environmental factors like dust, heat, mechanical wear out, different reactions. Its failure rate typically follow a bathtub curve. means there is a huge, kind of like chance of failure during the hardware development, like at the stage the when it is just developed, you will find the product is faulty. And if it is not faulty, then it will work steady. This is the steady state. Then after some time it will wear out, failure to due to aging components, like when the you are using the hardware, and over the period of time it will degrade due to different environmental factors, dirt, heat, mechanical changes, and there are other factors. So it's, as a physical component, it will always degrade, and that will lead to failure. So in contrast, software is not a physical entity, doesn't suffer from environmental degradation. Thus, in theory, software failure rates should decline over time as bugs are fixed and then remain flat indefinitely. Like at the beginning, you will find some bug, maybe you will fix it. Once you are done with the software, once you have developed a correct version of software, accurate software, then it will be useful forever. But there are factors, like when you have you the software does uh, deteriorate. Why? Because this continuous change and update, because now the demand is changing or the new requirements are coming. So if you are not able to update the software, then it will actually deteriorate. And poor managed code modifications, like the way somebody have written the code, when there is no change required, you are not able to find out where the code is written, how it is written, you cannot figure out the particular component, then you will not be able to make changes. So these are the things that is there in the question that explain the statement software doesn't wear out, with reference to the failure curves of hardware and software. Why does software still deteriorate over time despite not wearing out physically? This means this part, like it will not deteriorate due to the environmental changes, but there are factors which will actually lead the software to this condition, then it will deteriorate due to the continuous changes and update, poor managed code modifications, accumulated technical debt, increasing system complexity. If this thing happen, this thing are there, then definitely the software will not be useful. It means what? When the software is not useful, it means you can call it, it is deteriorated or degraded. Okay, so we'll meet in the next video, in the next lecture.